Finding the surface area of prisms with adamonlinetutoring. Here's the beginner question. Besides finding the surface area of cubes and cuboids, which are also types of prisms and have been covered in a previous video, this is one of the easiest questions that you're likely to find on this topic. The surface area of a 3D shape is the total area of all of the faces of the shape added together. When we have a prism, the face that we have on the front, or the cross-section, is the same as the face that we have on the back. Therefore, we can start by working out what the area of this face would be, which is a triangle. To work out the area of the triangle, I need to do base multiplied by the height divided by 2. My base is 0.4. Multiplying this by the height is 0.3, giving me 0.12. Half the base times the height, or divide it by 2, which is 0.06. But because we have two of the triangles, one at the front, one at the back, we then need to multiply the area of the triangle by 2, which brings us back to 0.12. So mathematically speaking, the right thing to do is to divide by 2 and times by 2, but because this gives us the same answer that we had before, if you remember to do it correctly, we could just leave this step out, knowing that it would bring us back to the same answer. Lastly, we need to work out the area of all of the rectangular faces. Now, even though some of these might appear to look the same, and sometimes they may be the same, but the majority of the time these faces will be different in area and size. The quick way to make sure that you multiply the correct lengths and widths is to first look at the lengths that wrap around the cross section or the front face. This would be 0.3, 0.4 and 0.5. This will give you one dimension of each of the rectangles, and the other dimension is a shared length, which is the depth of the shape. So all of these lengths would need to be multiplied by 0.9, which is the depth of the shape. Multiplying these together gives me 0.27, 0.36 and 0.45. Lastly, to finish off with, I just need to make sure that I add all of the correct areas together, starting with the area of the two triangles and the area of the rectangles, and adding these together gives me a total surface area of 1.2 meters squared. On to the intermediate question with an increase in difficulty, although the methodology behind it is exactly the same as the previous question. We can start by finding the area of the front face or the cross section. This is a compound shape made up of two or more shapes, which are more simple and we're used to finding the areas of. We can split this into two rectangles like this. Working out the first one, which I'm going to label as A, we can do 6 multiplied by 9 for length times width. This is 54. Next, we can work out the area of the other rectangle, which I'll label as B, and this will be worked out by doing 12 multiplied by 6, which is 72. Adding these together will give me the total area of the front face, which is 126. And remembering that there are two of these, one at the front, one at the back, giving me a total area of 252. Next, starting with 6, 9. This length needs to be worked out, but would be the difference between the longest one at the bottom, 12, and the one at the top, which is 6, meaning this length must also be 6 meters. This one is 6, the one across the bottom is 12, and the long one across the left-hand side would be worked out by adding this length and this length together to give me a total length of 15 meters. All of these rectangles share a common length, and that's the depth of the shape. The depth was given as 5 meters, so multiplying all of these by 5 is 30, 45, 30, 30 again, 60, and lastly 75. I can add all of these together, giving me 270, and this provides me with the two areas which I need to add together to give me the total surface area, which is 522 meters squared. On to the advanced question, one of the trickiest types of questions that you're likely to find on this topic. Again, using the same methodology covered with two previous prisms, I need to start by working out the area of the cross-section or the front face, which in this case is a trapezium. To work out the area of a trapezium, I need to use half the sum of the parallel sides multiplied by the perpendicular distance between them. The parallel sides are these two here, so find the sum of these or add them is 5x minus 3 plus 13x minus 3. Collecting like terms, I have 5x and 13x, which is 18x, and negative 3 adding negative 3 is the same as negative 3 take away 3, which is negative 6. Next, you need to half the sum of the parallel sides. So dividing this by 2 is 9x minus 3. And then you multiply by the perpendicular distance between the parallel sides, which is given as 3x. So 3x is multiplied by 9x minus 3. I'll need to consider a single bracket here so that I multiply both of the terms by 3x. 3x multiplied by 9x is 27x squared, and 3x multiplied by negative 3 is negative 9x. To finish off this part of the question, I'll have the same face on the front and the back, so multiplying these together will give me the area of both of these faces, leaving me with 54x squared minus 18x. The area of the rectangular faces that make up the depth of the shape can be worked out by first listing the lengths that wrap around the cross section. So firstly, I have 5x, 5x minus 3, 5x again, and then the one across the bottom is 13x minus 3. These all share a common depth and length, so can all be multiplied by this depth, which is x plus 2. I'll need to include brackets to multiply these expressions together. 5x bracket x plus 2. 5x minus 3 will need to go into a bracket and then multiplied by x plus 2. 5x bracket x plus 2. And 13x minus 3 will need to go into a bracket before multiplying by x plus 2. I'll assume you have knowledge of expanding single and double brackets. If not, I do have some videos on this in the expanding brackets playlist. 5x multiplied by x plus 2 is 5x squared plus 10x. 5x minus 3 times x plus 2 is 5x squared plus 7x take away 6. This one is the same as the top one, 5x squared plus 10x. And then 13x minus 3 times x plus 2 is 13x squared plus 23x take away 6. Lastly, to work out the total surface area, I need to collect like terms. The area of the front and back face have an x squared term with a coefficient of 54, and the rectangles have 5, 5, 5, and 13. Adding all of these together gives me 82 lots of x squared. Next, I have all of the coefficients of x, starting with negative 18, plus 10, plus 7, plus 10, plus 23, giving me a total of 32x. And lastly, I have some constants, negative 6, take away 6, which is negative 12, therefore showing that this is the same as the original expression which was given. Before you go, take a look at the solution which I've provided for this question. I've made some mistakes. Pause the video, see if you can tell me what they are, or write some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.